Hello friends, this lesson is all about questions on heat and work interaction. There are 10 objective questions in this particular lesson. Just go through these questions, try to solve these questions on your own. The answer key is on the last slide. These questions are very simple. You will find these type of question in GATE and Indian Engineering Series objective questions. But before proceeding for this question, just go through the theoretical part of heat and work interaction. Then these questions would be really simple for you all. But before proceeding through the questions, I would like to introduce myself. My name is Harshit Agarwal. This is all about me. You can always rate, review, recommend, and share this course. You can also follow me on the specified link. So to start with the very first question, first of all, try to solve by your own. The question says, for a simple closed system of a constant composition, the difference between the net heat and work interaction is identified as the change in. By the first law of thermodynamics, we know the equation as dq is equal to du plus dw, right? So the change in heat and work interaction, which is dq minus dw, is equal to du, right? So the change in heat interaction and work interaction is equal to change in internal energy. So it is not enthalpy, it is not workflow work, it is not entropy. The answer is internal energy. dq is equal to du plus dw. dq minus dw is equal to du, which is change in internal energy. Second question. Change in enthalpy in a closed system is equal to the heat transfer. If the reversible process takes place at, fine, I have derived the for the 5 processes there are different heat transfer. For constant volume, heat transfer is equal to change in internal energy. For constant pressure, heat transfer is equal to change in enthalpy. For constant temperature, heat transfer is equal to change in work transfer. For adiabatic heat transfer is equal to work transfer. For adiabatic, heat transfer is equal to 0. For polytropic heat transfer, we have derived the different equations for different processes. Here the question says change in enthalpy. So the change in enthalpy is a closed system is equal to the heat transferred at constant pressure. The answer is C. For question number second, the answer is C. Question third. In which one of the following processes in a closed system, the thermal energy transferred to a gas is completely converted to internal energy, resulting in an increase in gas temperature? See, the previous one was heat transfer is equal to change in enthalpy. This is heat transfer is equal to change in internal energy, which is at constant volume. At isochoric process, heat transfer is equal to change in internal energy for constant volume. B is adiabatic, which is 0. Isothermal heat transfer is equal to work transfer, and free expansion, it is altogether different, right? So here the answer is A, which is a isochoric process. The answer key is on a last. First of all, try to solve by your own. Fourth question. There is no work transfer involved. There is no work transfer involved in this process. Adiabatic, isothermal, polytropic. We have find that for adiabatic we have calculated the work transfer. For isothermal we have also calculated the work transfer. For polytropic expansion we have calculated the work transfer. But for free expansion we have discussed, for free expansion work transfer is equal to 0. Initial internal energy is equal to final internal energy. Initial temperature is equal to final temperature. So the no work transfer involved in this process. Which process? Free expansion. Is free expansion, work transfer is equal to 0. Question number 5th. This process is one in which there is only work interaction between the system and surrounding. Which process? देर इज ओनली सिर्फ और सिर्फ वर्क इंटरेक्शन रहेगा किस में? एडियाबेटिक प्रोसेस में. एडियाबेटिक प्रोसेस में हीट ट्रांसफर नहीं होता है, ओनली एंड ओनली वर्क ट्रांसफर होता है. बाकी डायबिटिक मींस हीट ट्रांसफर भी होता है, वर्क भी. आइसोथर्मल हीट ट्रांसफर वर्क ट्रांसफर बोथ. क्वासीस्टैटिक हीट ट्रांसफर वर्क ट्रांसफर बोथ. बट ओनली वर्क इंटरेक्शन विच इज ए एडियाबेटिक प्रोसेस. द आंसर फॉर क्वेश्चन नंबर 5th इज बी. क्वेश्चन नंबर 6th. Match the list. Different work transfer for different processes. Work transfer in a polytropic process, we have derived the formula for this: P1 V1 minus P2 V2 upon n minus 1. So for A it is 4th. So either option A is correct or option C is correct. B is not correct and D is not correct. So answer is from either A or C. Work done in a polytropic process is equal to P1 V1 minus P2 V2 upon n minus 1. Work done in steady flow processes. In steady flow processes, work done is equal to what? It is equal to minus VDP. We will see that. We will see in the upcoming lesson. In steady flow process, work done is equal to minus VDP. Work transfer in reversible adiabatic process, P1 V1 minus P2 V2 upon gamma minus. Polytropic में P1 V1 minus P2 V2 upon N minus 1. Reversible adiabatic P1 V1 minus P2 V2 upon gamma minus 1. D. Work done in a isentropic process. Work done in a reversible adiabatic process and work done in a isentropic process, it is 3. And heat transfer, C, first of all, in C, heat transfer in a reversible adiabatic process is 0. It is given as heat transfer. Sorry from my side. It is given as heat transfer. Heat transfer in reversible adiabatic process is 0. And work done in an isentropic process is reversible adiabatic, which is P1 V1 minus P2 V2 upon gamma minus 1. The answer for this particular question is C. Work done in polytropic process, P1 V1 minus P2 V2 upon N minus 1. Work done in steady flow process is equal to minus VDP. Heat transfer in reversible adiabatic process is equal to 0. And work done in isentropic process is P1 V1 minus P2 V2 upon gamma minus 1. So the answer is C. Question number 7th. Identify the process for which the two integrals, integral PdV and minus integral VdP, evaluated between any two given states give the same value. See, it is not isenthalpic. You know the equation for isothermal process. For ideal gas, it is equal to PV is equal to MRT. M is constant, R is constant, and we have taken the isothermal process, temperature is constant. Right? Temperature is constant. So if we will take the derivative of left hand side and right hand side, derivative of PV is equal to derivative of constant. Derivative of PV is equal to PdV plus VdP is equal to 0. So PdV is equal to minus time VdP. If we will take the integral, it is integral PdV is equal to minus time integral VdP. So it is for which process? It is for isothermal process. It is not isenthalpic process. It is not isentropic. It is not polytropic. It is isothermal process. Just go through this particular question. Try to solve this question on your own. It would be very simple. The question says two integral PdV and integral VdP. The values are same for both the integral. Which is that process? That process is a isothermal process. Question 8. A closed system receives 60 kilojoule of heat. Heat is given into the system. So the value of dQ is plus 60. But its internal energy decreases by 30. The value of du is minus 30. The first law of thermodynamics says dQ is equal to du plus dW. Heat transfer to the system is taken as positive. It is equal to plus 60 kilojoule. The value of du is minus 30. And then the work done by the system is 60 plus 30 is equal to 90 kilojoule. The answer here is A. So answer for question number 8 is A, which is 90 kilojoule. See, Q is plus 60, du is minus 30, dq is equal to du plus dw, 60 minus 30 plus dw is equal to 90 kilojoule. Question 9th. This is a very interesting question. The question says, the data given in the table refers to an engine based on Carnot cycle, where Q1 is heat received in kilojoule per minute, Q2 is heat rejected in kilojoule per second, W is in kilowatt. Q1 it is in per minute. First of all, converted it to per second, because Q2 is in per second and W is in per second. If the heat received by the engine is 2000 kilojoule per minute, the work output would be nearly. Heat received by the engine is 2000 kilojoule per minute, the work output would be nearly. See, first is Q1 is 1500, Q2 is 16.8, W is 8.2. We have to first of all calculate the efficiency for first part, it is W by Q1. Calculate the efficiency for second, it is W by Q1. Calculate the efficiency for third, which is equal to W by Q1. And calculate the efficiency for fourth, it is W by Q1. So you will see that the efficiency is same for all 32.8. For first one, the efficiency is 32.8. For second, the efficiency is 32.8. For third, the efficiency is 32.8. And for fourth also, the efficiency is 32.8. So the question says now the heat engine received 2000, the value of Q1. Q1 का value दिया है 2000 kilojoule per minute. हमें work output निकालना है. The work output would be nearly. So efficiency is equal to work output upon heat input. So efficiency would remain same, which is equal to 32.8. Fine. So work is equal to Q1 minus Q2. Efficiency is same, 0.328 W upon Q1. convert it into kilojoule per second. So W comes out to be 10.93 kilowatt. W comes out to be 10.93 kilowatt. Again, the question says the value of Q1 is given in kilojoule per minute. First of all, convert it into kilojoule per second. Then this is the value in kilojoule per second. This is the value of W. Heat received by the engine is 2000 kilojoule per engine. Then the work output would be nearly, we have to calculate the work output. Fine. So this is the value of W, and this is the value of Q1. If you will find the efficiency for first is 32.8, second it is 32.8, third is equal to 32.8, fourth is equal to 32.8. We have to calculate the W. Efficiency is equal to W upon Q1. Efficiency is 0.328. W upon Q1. W, the value of W is 10.93, which is the answer is B, 10.93, which is fine, 10.39. Last question. The last question says a 4 kilowatt rating is given as 4 kilowatt. 20-liter water heater is switched on for 10 minutes. For how many minutes? 10 minutes. The heat capacity CP for water is 4 kilojoule per kg Kelvin. Assuming all the electric energy has gone into heating the water, the increase of the water temperature is, the specific heat of water is given as 4 kilojoule per kg Kelvin. All the electric energy gone into heating the water, the increase of water is this much. 4 kilowatt W. Q is given as 4 kilowatt. Mass density of water we can take as 1000. Volume is 10 liter, 20 liter, which is 20 into 1000 cc. Fine, with mass is equal, density is equal to mass upon volume. Mass is equal to density into volume. Right. So 4 kilowatt rating, 4 into 1000 into 10 into 60, which is 4 into 10 into 60 kilojoule. Mass into specific heat into delta T. Q is equal to 4 into 10 into 60. Mass is equal to density into volume, which is equal to 20. Specific heat is 4. We have to find the increase in temperature. Increase in temperature comes out to be 30 degrees Celsius. This numerical is very easy. You can go through these numericals. If you have any doubt, you can ask me. If you want more these types of questions, you can ask me. This is the answer key of all the questions. Just go through them. Thanks a lot from my side. This is Harshit.